So we are starting our modeling with graphs unit, and lesson 1 is called Analyze Data. Uh, we are going to be doing a lot of graphing, and in order to graph relationships, we would normally collect data. We would come up with a hypothesis. So a hypothesis is a theory or statement that is either true or false. You would collect data then to either support your theory, hypothesis, or to it may prove your hypothesis to be false. A hypothesis is often a statement that might include things like, if this happens, then that happens. You can use statistics to test whether the hypothesis is likely to be true. Statistics is numerical data. There is a grade 12 math course you can take called data management, and you will study a lot of this in that course if you end up taking that when you're in grade 12. So statistics, it's either numerical data or the collection, organization, and analysis of numerical data. So in order to get into graphing, this is just a little bit of a background because we would always need to collect data in order to have something to graph. Example 1, write a hypothesis about a relationship between the variables in each pair. So a hypothesis, we're looking for a statement or a theory that is either true or false. So a driver's age and the risk of having an accident. So we could look at this in different ways. It's just a theory that we come up with. So let's say that, well, I know you're young, so you might say, as a driver gets older, the risk of having an accident increases. I might think of younger people having more accidents than older people, but let's just imagine that older people would get into more accidents. So we could imagine this as a little graph, so not with any numbers or values right now, but imagine a graph, and we think of somebody being 16, and as they get older, so if this is their age, as they get older, the number of accidents they're having increases. So you can imagine that the graph, maybe the line would be going up. It is important that this would be the cause and this would be the effect. And that is usually what we would come up with a hypothesis. So as their age increases, the number of accidents they have go up. Attendance and school marks. So we think about people being away a lot, and if you're absent a lot, then maybe their marks would go down. So that could be a hypothesis. So if students have a lot of absences, then their marks decrease. How this would look, the absences are the cause. So absences would need to go on the x-axis, and marks would go on the y-axis. And the more absences they have, their marks are actually going to decrease. So the line, if you could imagine, might look something like that on a graph. And then a student's age and their height. So you could imagine that as students get older, their height would increase because they're going to grow taller. So since age is causing the height to increase, their height doesn't change their age, but their age would be the cause. So we would put age and we would put height on our vertical axis. And you could imagine if we had a lot of data and points that as students get older, they're going to get taller. So you can kind of imagine the line going up. So data sources, we can have primary data or secondary data. So primary data would be original data that a researcher gathers themselves, either by doing an experiment or conducting a survey. Secondary data is data that someone else has already gathered, and we can either go to a website or we can collect that data from someone else. So example 2, explain whether each set of data is primary or secondary. So Daniel phones 100 families in his town to ask them how many pets they have. Definitely that would be primary data. So the phone interviews produce primary data because he collected it himself. Kathy used data from Statistics Canada to determine the proportion of households in Canada that have at least one car. Kathy is using the data from StatsCan. There are statisticians who have collected that data, but she didn't collect it herself. So this is secondary data. Okay, we're going to talk just a little bit about sampling. So a sample, any group of people or items selected from a population, and a population is the whole group of people or items being studied. A census is a survey of all members of a population. So when we do a census, for example, in Canada, they are really trying to survey every person, every household in Canada who is of age to do the survey. A sample is just a small selection of people or items from a population. So if a population was Canada and we just took a sample from Canada, that might just be a certain number of people from each province. A population, you don't need the population to be all of Canada or like all of the world. The population could just be an entire classroom. Our class could be our population, and a sample would be just certain students in our class. So a population doesn't have to be as big as you might think. Example 3, identify the population in each situation. So a teacher wishes to know how early his students wake up in the morning. So the population in that situation is just the students in his class. The principal of a school with 700 students wants to find out how much homework her students are doing each day. So they're looking at a school of 700 students, so that would be the population in this situation, just the 700 students at the school. A clothing store needs to find out whether its customers are happy with its service. So the clothing store has customers, and those customers end up being the population. A polling firm wants to know how people will vote in the next federal election. So we're talking about all of Canada. The population here would be everyone who would be voting in that federal election. So sampling techniques. Now that we understand what a population is, how do we get a sample from that population? So you would learn a lot more sampling techniques if you take data management, but sampling techniques for now, just a few. A simple random sample, choosing a specific number of members randomly from the entire population. So simple random sample. If we had a classroom, it would just be like drawing names out of a hat, just a random sample of names. There's something called systematic random sampling, choosing members of a population at fixed intervals from a randomly selected member. So let's say you pick the 25th person in the school alphabetically, and then we're going to go at a fixed interval. So that's an important word there. Like we're going to choose every 50th student or every 10th student. Regular intervals for systematic, and then stratified random sampling, dividing the population into distinct groups, and then choosing the same fraction. This is proportional. So let's say our school population had 500 girls and 200 boys. So there's going to be a lot more girls than boys. If we were going to do a stratified random sample, we would definitely choose for the sample then more girls than boys, and it would be proportional to the number of girls and boys at the school. So there's just a few sampling techniques. Sometimes people use samples that are not randomly chosen. Non-random sampling can be cheaper and more convenient, but the results are less likely to be accurate. You don't want to have bias in your sample. So the last example, example 4, identify the type of sampling in each situation. So the personnel department sends questionnaires to 75 employees randomly selected from a list of everyone working at the company. So this is just a simple random sample. A computer randomly chooses one name from an alphabetical list of a store's customers, and then also selects every 25th person listed before and after that name. So because it's every 25th, this is called systematic random sampling. And then the student council of a school randomly selects a number of students from each class. This number is proportional to the size of the class. So the word proportional to the size of the class, this would be a stratified random sample.